Greetings to you all. I'm Derek Korn, Executive Editor of Modern Machine Shop Magazine. Welcome to Faster, Easier, Safer NC Programming with Cimatron Software, a webinar sponsored by 3D Systems. Thanks for joining us. New technologies are now available to help you achieve faster machining, simpler programming, and higher surface quality. Today's webinar will demonstrate the latest capabilities in 3D Systems Cimatron software that can help you accomplish this and more. So to that end, we'll cover new cutting strategies such as use of barrel, oval, and lens cutters, feature-based machining, faster remachining programming with a guided cleanup application, and 5-axis tilting. Our presenters today are Dan Branch, Customer Support Manager for 3D Systems, and Alon Leister, the company's CNC Technologies Specialist. Today's presentation will be followed by a Q&A session. It's easy to submit questions, and I encourage you to do so during the presentation. Simply type your question into the question pane on your screen, and we will do our best to get to all of them. So let's get started. Dan, please take it away.
Thanks, Derek. To begin with, I'm going to take a minute to share with you a little information about 3D Systems. 3D Systems provides comprehensive 3D products and services, including 3D printers, print materials, on-demand manufacturing services, and end-to-end software solutions. The markets that 3D Systems services include aerospace, automotive, consumer goods, jewelry, medical, and dental. With industry-leading engineering software and 3D printers, 3D Systems delivers the solutions you need to empower your business growth. And this slide is an illustration of the broad printer and software portfolio that 3D Systems has to offer. Each has a well-defined niche for a segment of that market. The suite of software offered by 3D Systems has been designed to provide solutions for both subtractive and additive manufacturing to help you cover every stage of the manufacturing process. Today, we will be focusing on just one of the subtractive manufacturing solutions, specifically the Cimatron software for NC. Cimatron itself is an integrated CAD/CAM system designed for tool makers. Because tool making is our primary focus, Cimatron has developed a host of specialty functions that deliver major advantages for mold, for die, and manufacturing shops, keeping you more competitive across your entire range of operations. As I mentioned previously, today we will be looking at just the NC side of Cimatron and how you can achieve faster, easier, and safer NC programming results. And with that, I would like to turn the floor over to Alon, and he's going to begin our presentation.
Hello, everyone. Thank you, Dan. So manufacturers have a lot of challenges and targets to fulfill. Faster machining, superior surface quality, simpler and more automated programming, and better machine utilization. Some of those challenges may be contradicting, like faster machining can be contradicting superior surface quality. So it's very interesting how we can combine all those targets, and let us jump in and see how Cimatron can handle all those and offer you the best solution for each of those challenges. Clicking then. So starting with faster machining, we will look at faster finishing using barrel tools and faster rough machining. We know that surface quality relies mostly on the scallop, and the scallop is a combination of the cutting tool radius and the step over, as we can see on the drawing on the left side of the screen. So utilizing barrel tools family like the barrel, lens, and oval tools, we can utilize a much bigger active radius or cutting radius for yet a small tool diameter and achieve same surface quality but with a much bigger step over. And a bigger step over means faster finishing. So here is an example of a very simple demo utilizing 3 tools. On the left side, we will use the lens tool for the horizontal areas. In the middle picture, we will use the standard ball tool for the transition area between the horizontal and the vertical walls. And on the right side, we will use the oval tool with the very big oval tool radius for the steep areas, the steep walls. The test cut, sorry, one click up, then. The test cut is a small aluminum piece, 150 by 75 by 60 millimeters. And on the right side, we can see a picture of the piece cut in both methods. Left side will be the standard tool, the ball tools, and the right side will be the barrel tools family. So starting with the shallow areas, in this case the top of the job, left side is with the standard ball 10 mm and the right side with the lens tool. The lens tool radius is 20 millimeters, so we can see that for the same scallop we can use, instead of step over of 0.24, we can use a double step over of 0.49 millimeter, and if it's a double step over, it's a half time. So cut time goes from 10 minutes down to 5 minutes. On the steep areas, what we call the above slope, we can use the very big radius of the oval tool with a radius of 85 millimeters, and this means we can increase the step over, or the down step in this case, to 1 millimeter compared to 0.25 or 0.24, and this means a 4 times bigger down step and a 4 times faster machining. Instead of 20 minutes, just 5 minutes. Let us have a look at this movie now. So let us focus on the right side because it's running very fast. Starting with the lens is finished, and now the oval, and that's done. And yet on the left side, the traditional cut is being running on and on until completed. And this is resembling the real machining time as it will be on the machine. Now we are seeing in parallel right side with the oval tool and the left side with the standard tool, and we can see how the oval tool runs bigger downstep and cuts much faster compared to the standard milling. So this is utilizing, and this is effectively good to shorten finishing time, yet get the best same surface quality as we are used to with the ball cutters. Switching to the roughing, here, not speaking of the high performance roughing, but the standard roughing, utilizing efficient connection and improved clean between passes and improved ridges. All those are terms of the algorithm, but the bottom line for us, for the users, is utilizing a better roughing toolpath that can increase the roughing up to by 20%, at peak cases even up to 40%. Here, let us look at case 1 study. So, customer was cutting a job at a competitor software with 15 hours and a half. So this is a medium-sized job. On Cimatron version 13, it took 17 and a half hours. This is why it is colored in red, because it was not fast enough. So we at Cimatron, we thought, how can we increase the roughing process? And we came out with version 14 down to less than 14 hours, which is 21% improvement on the roughing time. This is very significant, taking into account the machine cost per hour, which is can be a lot of money for the manufacturer. Next case is even a bigger job. Cimatron 13 took about 22 hours total rough process, and this process was first rough and then re-rough 1 till re-rough 4. And compare that with Cimatron 14, we are seeing that the first rough actually was almost the same time. So we couldn't improve in this case the basic rough because we were already very efficient at that stage, and basically starting off from a full block, the toolpath was efficient enough. But focusing on the re-rough processes 1 to 4, we can see increase in efficiency of 27%, 13%, 40%, and 41% per process or per procedure. This means we have saved a lot of air motion and unnecessary movements, yet keeping the very safe toolpath to protect the tool from breaking or the piece from being damaged. So this is very significant, and we've done that knowing better the stock condition, and we update the stock and we know exactly where to place the tool and how fast can we cut at each position in order to maintain the safety yet run a faster toolpath. And this is very impressive. Moving on to the next item, the superior surface quality. So here we have two items, the 5-axis tilting and the fine surface quality as it is. 5-axis tilting, as you know, will be utilized when we need to use small diameter tools and get to very deep points inside a piece like a mold or any other component, and we would like to utilize the machine faster and safer and minimize vibration and increase feed and so on. So a powerful 5-axis toolpath can help us with smooth machine axis movement and minimize or no machine vibration, so achieve the high surface quality. Let us have a look at this movie, please. So first we are seeing the table is being rotated only when the holder is close to the job, and when the holder is away from the job, the table is rotating back. So this motion of back and forth causes backlash and may cause different axis unnecessary motions. They will not cause any gouges, but they will cause bad surface quality. Now looking at the picture, we are seeing a stable tilt position of the table while only C-axis is rotating. So you could call that even 4+1, which is actually better than 5. And on the algorithm side, how funny it may look, it's even more complex to program, or for the users it's very easy. For the algorithm it will be more complex. Higher surface quality with 5-axis tilting, we can convert 3-axis toolpath into 5-axis. We separate the 3-axis from the 5-axis operation. So while editing the 5-axis portion, there is no need to recalculate the 3-axis portion. We are saving calculation time. We are more flexible. Plus, the user can specify any guiding contour or guiding point or a set of contours for simple geometries like electrodes or other simple components. The user most of the time will know what should be the direction of the tilting and which contour will be best for tilting. So we are kind of helping the algorithm to find the best solution, the more canonic solution, and this is faster in calculation and better result. Let us have a look at the movie. So starting with the 3-axis toolpath, we can program just a standard 3-axis cleanup in this case with a small diameter tool, and expecting that the holder might collide with the job. So of course this is not good. Now we have to apply on that 3-axis toolpath the convert to 5-axis, and this is pretty easy, and very few parameters. In this case the user will pick a circle around this boss, specify the tilt angle, which is in this case, for example, 10 degrees, constant, and activate the calculation, and it's very fast. And now it's the user's responsibility to check the result. Other option is to apply the gauge check on, and then it will be the system's responsibility to prevent collision and gouges. Here we see the simulation, and notice that the B angle is constant 23.76 in this case, constant angle. And here it's the cut. Again, the table doesn't rotate, only the C axis. So this means a stable machining and a better surface quality. Next item will be the fine surface quality. This is just a parameter in the software for all finish and cleanup procedures. It makes a big difference. Let us see, left side is what we call the standard toolpath, and right side is the fine surface quality toolpath. We can see on the left side some marks on the job, and please take into account same tool, same machine, same feed, same conditions, everything is the same material, yet left side will leave marks on the job that need to be polished, and the right side is a fine surface quality, many times no need to polish at all. So the question, how is it done? It's done by the very smart algorithm that Cimatron has for the finish and cleanup procedures. Calculation time will be longer. Then, could you forward please? Okay. Here we are seeing a benchmark at a huge mold maker in China. We see 4 competitors. Okay, we don't mention the names of the competitors. We can see competitor 1, Cimatron, competitor 2 and 3. 2 were disqualified, and zooming in the 2 runners-up, competitor 1 left side left some marks on the job, and Cimatron, the result was perfect, no need to polish. And this is due to this parameter called in the software fine surface quality. Moving on to the next item, the programming. Programming is a very big issue as we proceed with all the options. We need yet to simplify the programming and make it automated and standardized for the users to be able to faster and easier program and get the best out of the software. So here I'll focus on 2 issues: feature-based machining and guided cleanup. Feature-based machining is a complete solution. It is included in the Cimatron NC sheet, or it can be a dedicated, what we call a plate automation seat. The idea is easy, fast, and safe programming going throughout all the issues related to features, simple features machining. This will include facing, the pocket manager, which is the main engine or the main algorithm to identify which features to be machined, then the pocket templates that will be applied on those pockets from the pocket manager, then chamfering procedure with auto detection, and a very capable automated drill with a lot of sequences and capabilities. Starting with the facing procedure, this is so easy. The user needs to define nothing. No Z values, no contours. The stock is known, the part is known. The user needs just to specify the tool and the cutting conditions, and then the algorithm calculates everything automatically. The pocket manager is the heart of the feature-based machining. This is a very strong algorithm that identifies the features or the pocket features from various directions. Then it can analyze them by type, like tapered pockets and straight pockets and open pockets and closed pockets and round pockets and non-round pockets and so on. And then the user can filter out which pockets you would like to select, and on those you will apply the templates as said before. The templates are not something that the software supplies. The user normally is working with the system, as you are working with the system in your facility, with your tools, with your materials, with your kind of jobs. Whenever you have a nice job, you can save that as a template. And this template you can later on use again on a similar job or on a family of jobs related to that. And the templates can be just organized in your disk under various names like material, steel, aluminum, or so on, or by a name of a customer, or by a name of a machine, and so on. So the ordering is done by the user, and the templates are created by the user, not as an extra work, but as you work, you are saving more and more templates as you are familiar with your jobs. Left picture on the chamfering, we have the auto detect. The detection can be on imaginary chamfers or on real chamfers. Imaginary chamfers are actually sharp edges on the job where there is no chamfer, not designed or doesn't exist. And we would like to machine that imaginary chamfer. Other option will be select all the real chamfer and auto-detect those. And on the right picture, we see the holder collision avoidance, which will save the job or save the tool from clashing into the job. So this is done automatically. Let us now look at the complete process of feature-based machining start to end. So this is a 2-minute movie by Cimatron, feature-based machining. In this case, we will see a job which is about 600 millimeter with quite few pockets and quite complex. Starting with the automated facing procedure, as I mentioned, easy to program, just apply facing, system analyzes the stock and the part, and you get the facing procedure. And this is the toolpath. Next would be the pocket recognition, which is the heart of the feature-based machining. Apply the pocket manager, and the system analyzes, in this case, I don't know how many, 60 to 70 pockets from different directions. You can sort out and filter which pockets are not of your interest at the moment and from which UCS or from which direction are you interested now to machine. So easily you can filter out, like in this case, the central pocket, which is a tapered pocket, and we are left with 4 straight open pockets, different in size and dimension. Those pockets now we would like to apply on a template which will do the complete process, like the rough, the semi-rough, the 2D cleanup, the wall finish, the floor finish, and the chamfering. So we will now go and apply template and look in our disk which template or which set of templates is fit to this kind of job. So browsing through the disk, finding the material and the similar family of jobs related to these kind of pockets, and we can see, clicking on each procedure template, we will see the respective picture explaining which or what is this template going to do. Selecting all those, we can now apply on the job, and next we can apply the automatic chamfering on the 4 pockets. System finds the chamfers, we can select which one we would like to use, and programming is done. Now the simulation, it will summarize the complete process start to end. Looking at the full stock, we can see now the facing procedure, the roughing. So it will rough all the pockets and not one by one, and then wall finishing, and then floor finishing, and then dealing with the main tapered pocket with a different template or manual options, and then chamfering, and finally automated drill with all its sequences, groups, and capabilities. So feature-based machining, safer, easier, and faster programming. Next, then, okay, guided cleanup application. This is an application that helps us guide and manage remachining process. This is fast, safe, and efficient remachining programming for large complex components mostly, like bumper mold, grill mold, and all kind of big jobs, not just, cubes of 100 millimeters, but the complex jobs. Mostly these jobs we will program by using 3+2 positioning, and we would like for each portion of the job to know which is the best direction that will fit the machine head and the job. So this can be a tedious job, can be complex, and for that we have 2 stages. The first stage is called the remachine segments. On the screen we are seeing the system finds all the unmachined regions, we call segments, for a previously used reference cutter. The data is displayed both in the graphic area as contours with errors and also with a table. Now the user can control for each segment which direction he would like to use. User can trim, split, delete segments, operate on the segments, and this is very fast because the actual cleanup toolpath has not been calculated yet. So this is like the planning stage. This is the guiding stage. And here the user can spend a lot of time planning, checking, and finding the best direction per segment. Next will be applying the procedures. There are 2 kinds of procedures we offer. One is called the guided cleanup, and one is called the multi-axis guided cleanup. Focusing on the multi-axis guided cleanup, this is 3 plus 2, and this means once all the directions have been defined, this procedure, it's a one click, it will calculate everything, and hopefully, because we have already found all the directions in the segment manager, now the result will be gouge-free and collision-free and ready to mill. So the usage will be milling each segment accordingly, according to its predefined directions. Let us see the movie. So here is a typical job. We can see a very complex job, and the machine has a non-symmetrical head, and the head is big and plunges into the job. Starting with the segment manager, we are now applying the previous cutter on the job. This job, of course, is schematic, just to show the concept. We are selecting the tool and the surfaces and the tolerances and so forth. And now, using the segment edit segment manager, for each segment we can specify the tilt angle. We can do that manually by clicking the arrows or setting the value, copying the orientation from one segment to the other, splitting segments, checking collisions of segments. All this is done in this planning environment, which is fast and easy to understand. And once done, we are just applying all those segments to the multi-axis guided cleanup procedure, calculating. No need to set only cutting conditions like downstep, sidestep, feed, and spin, and so on. And the result is a complete 3 plus 2 axis toolpath. And going directly to the machine simulator, we are expecting to see the safe toolpath as it was planned already. We do not expect any surprises. And this is the operation. The head is plunging into the job, but safely it doesn't collide with the job because we have planned it okay before the toolpath calculation. So this is, as I said, helpful for the complex jobs and not just for the very simple jobs. Better machine utilization. We have in-process measurement and interface to Makino. Machine utilization today is a very strong issue because the machines are expensive and the shop floor, we want to minimize handling of heavy jobs between machines and operations. So in-process measurement, if we could measure things like dimensions on the machine while the part is being machined and compensate and mill again, measure again, and get the correct part right off from the CNC machine, we can save time and we can utilize our machinery better. So this is best shop floor utilization, quality parts right off from the CNC machine, less part handling, and optimal material setup. We are seeing 3 operations with IPM in-process measurement. On the left side, we are seeing machine home setup. Middle, in-process measurement, different options shown here by the different tiles of what can be measured, and also the option called on-machine inspection to measure several points, many points, after a job has been milled. Let us have a look at the movie, please. So here is a job mounted on this 5-axis CNC machine, starting with angle measurement to align the C-axis of this 5-axis machine. After aligning the C-axis, we will actually say that X-axis is parallel to the job as mounted. Then we can measure the center of X and apply that like G55, G54, X center, then Y center, and then measure a point on Z, and we have Z center. And by that, we have optimized the position of the job, and we have set the correct place for the home. Now comes a standard profile milling, but with scatter compensation. And then comes measuring of this slot width with the special option called action. And in the action, you can specify a condition. If the slot is not wide enough, call the milling profiling operation again. And this can be done only on real time on the controller. We cannot anticipate how the machine will behave. Now we are seeing the complete simulation start to end. And this is the C-axis alignment, X center, rotation of the job for Y centering. So we are seeing the simulation of the probe. And now actual milling will start. Any operation is available, in this case profiling. And then call the probe to measure the width. And if the width is not enough, the measurement will activate calling the profile again and measure again. So we ensuring that the part coming out from that operation is already in position and in dimension. And this is very interesting. Interface to Makino CSG. This is a very interesting thing done by Makino company. What is Makino CSG? This is collision safeguard. This is on the CNC machine, they have installed a parallel computer that in a real time it will prevent any collision on the CNC machine. It's installed today as default on all 5-axis CNC machines, so it's very interesting to watch that. It checks all the components on the machine working environment, the part, the stock, the tools, the holder, and it will check all modes of work. It means our CNC G-code program, of course, but it will also check manual operator's jog and MDI manual command, like I type in X100, apply, and if at 95 millimeters the machine is about to crash, it will stop. The axis physically stop. I have been in Makino headquarters in Japan, and I have seen it with my own eyes. And, oh, one back then. So, what is it? In Cimatron, it's very simple. It's a direct interface from Cimatron to Makino. Actually, we know all the information in the cam side, so we zip all the information as a file and send that to the controller, and from that point on, everything is automatic and the safe position or the safe methodology is on. So it's very interesting. So by that, I would like to summarize. With all these new technologies, you can optimize your machining strategies and get high quality products out the door faster. So thank you. This was my presentation, and we can move to the questions.
Thank you. That was a helpful presentation. Now, before we transition to the Q&A session, I do want to mention that the webinar is being recorded, and attendees will receive a follow-up email with a link to it, so you can revisit this whenever you like. We've gotten a few questions from the audience already, but there's still time for you to submit one. Go ahead and type it into the question pane at the right of your screen. Best